So here are our standards. Here are our learning targets. All right, so when you have a right triangle, it's made up of 3 parts. You have 2 legs. Those 2 legs always form the 90-degree angle. And then you have the longest side. The longest side of any right triangle is across from the right angle. Okay, so here's our right angle right here. Diagonal from the right angle is the longest side, and it is called a hypotenuse. That's its name. So the legs are the two shorter sides, and those 2 legs come together to make your right angle. And across from that is the hypotenuse. You must be able to identify the legs and the hypotenuse of the right triangle. That's very important, because when you're using the Pythagorean theorem, you have to know which numbers to use for the legs and which number to use for the hypotenuse. Are there any questions? Could all of you identify the 2 legs and the hypotenuse of any right triangle?
I can.
You can? Who can? Who else can? You can identify the 2 legs and the hypotenuse of any right triangle. Okay, I see some heads nodding yes. Okay, so like I said, all of this was on yesterday's video. I hope you watched it. All right, so basically what Pythagorean or Pythagoras discovered was, let me show you a video. Okay, look at this thing. So in the middle here, there's a right triangle. Do you see that? Well, if you take each side length and you square it to make a perfect square for the 2 legs. Now watch what he's actually doing. He's taking both of those squares and he's pouring them into the biggest square, and they fit perfectly. And that's what Pythagoras discovered. He discovered that if you take the legs and square them, add them together, you will get the 3rd side squared. Okay, what in the world are you talking about? All right, so anyway, this is his discovery right here. A squared plus B squared equals C squared. So you take the 2 legs, you square them both, you add them together, and that's always going to equal the longest side squared. And this is a great example of what that looks like. All right, so you can come back later if you want to and watch this awesome BrainPop video. You will need to log into BrainPop through your lunch point first in order to get this video to open. All right, so here is our first example. So we have a right triangle. First of all, we have to identify that right angle so we can figure out what the 2 legs are. So the 2 legs are 3 and 4, right? The longest side is the hypotenuse. So the Pythagorean theorem says if we square the 2 legs and add them together, we will get exactly the longest side squared. So if we have one leg that's 3 units long and the other leg is 4 units long, that should equal the longest side squared, which the longest side is 5. So what is 3 squared, guys? What's 3 times 3? 3 times 3.
9.
9. What is 4 squared? Tell me, Colin.
It's 16.
It is 16. And so do you notice that's actually the area of these squares that come off each of these sides. 4 squared is 16. It makes a perfect square. And then 5 squared is 25, right? So do you guys agree with this statement? Does 9 plus 16 equal 25?
Yes.
Yes, that's exactly right. And so that's what Pythagoras discovered, not only with a 3, 4, 5 triangle, but any right triangle has the same relationship. Any questions? Perfect. Okie dokie. All right. So the important part, like I said earlier, is you must use letter C for the hypotenuse every single time. A and B are interchangeable. It doesn't matter if you use this side for A or this side for B. Same thing for this side. Doesn't matter if you use the letter A or B, but the hypotenuse must always be the longest side. Okay, so it says if the squares of sides A and B do not equal the square of C, then it is not a right triangle. For example, let's say I said, all right, guys, you have to prove to me whether a 2, I don't know, 4 and 6 unit triangle is a right triangle. Well, the way to find that is by using the Pythagorean theorem. So either it is a right triangle or it's not. So what we're going to do is we're going to take these two smaller numbers, because those must be the legs. The two smaller numbers must be the two legs. The longest number, the biggest number must be the C. And we're going to plug them into the Pythagorean theorem. So 2 squared plus 4 squared. Does that in fact equal 6 squared? Well, let's see. 2 times 2 is 4. 4 times 4 is 16. And 6 times 6 is 36. Is this statement true? Does 4 plus 16 equal 36? That is not true. Because what is that? 20, right? Yeah. 20 does not, in fact, equal 36. So if this were the question, is this a right triangle? The answer would be no, of course not, silly. And that's the way we would prove it, by using the Pythagorean theorem. Everybody good? Okie dokie. Perfect. Thank you for answering me when I ask y'all questions. Y'all are the best. Oh, and they used another group of numbers, 4 plus 6 plus 10. Now, even though y'all agree that 4 plus 6 does equal 10, right? A lot of kids get that confused and they think, okay, if I add the two legs together and get the number of the longest side, then that's the answer is true. No, you have to square all the numbers. Okay, so don't make that mistake. That is a common mistake that I see over and over again. All right, if you need to come back later and you may see this awesome video by Mr. Mathantics, and he's actually, you know what? It looks like he's in Greece talking about Pythagoras. So that would be an interesting video to you to watch if you need to. All right, so you guys tell me, are these combinations of numbers, are they actually able to create a right triangle? Now, always remember, guys, every time, what must you use for C? What must C always be, no matter what order the
The
numbers are
biggest
written?
one.
It must be the biggest number. All right, I want you guys to try. I want you to, let's go ahead and number them. So this will be number 1, this will be number 2, this will be number 3, and this will be number 4. So when you chat me your answers are either yes or no. Yes, these create a right triangle, or no, they don't. All right, I want answers from everyone. Ready, set, go. Good, Colin, you got them all, buddy. Good. Allie, number 4 is right. Zabdi, number 2 is not right. Colton, number 1 is right. Jackson, number 1 is right. Allie, 2 and 3 are right. Rylan, 1 and 2 are not right. Claire, number 1 is not right. Allie, number 1 was right. Number 1, Darius, is not right. Zabdi, number 4 is not right. Forrest. Ashlyn, you got them all. Good, 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 good. Yes, Ashlyn, good, good, good. Rylan, yes, very good. Good, Isaiah, number 1 is right. Good, Hamina, that's right. Good, Darius. Kaden, send me some answers. Claire, send me some answers. Colton, correct. Rylan. Oh, yeah, we'll go over it. I know, but okay. So someone's telling me, guys, someone's telling me number 1 can't be yes because 18 plus 24 does not equal 30. Is that how we know the answer is what it is? No, what are we forgetting? You have,
Square.
yes, it's not 18 plus 24 is 30. It's 18 squared plus 24 squared has to equal 30 squared. Big difference. Yep, yep, yep. Hayden, number 4 is correct. Good, Colton. Number 1 is Hayden. You didn't get number 1 right. That's the only one you missed. Isaiah, I disagree with your last answer, I'm afraid. Jackson, I agree with your last answer. All right. Right, Jimena, very good. Yes, Hayden. Good, Colton. All right, so can I move on? Caleb, you ready, buddy? Yeah. All right, so our answers are yes, yes, no, no. Yes, yes, no, no. All right, because I don't know what 18 squared is, and I don't know what 24 squared is, but I know that 30 squared is 900, and I know that when you square these two numbers and add them together, they do equal 900. Right on? Yes, that's why the answer is yes. All right, number 2, we're going to square the two smaller sides. 15 must be the hypotenuse, okay? 81 plus 144 does, in fact, equal 200, what would that be? 25? Yeah, I think so, right? All right, number 3, 2 squared plus 3 squared is not 4 squared. 2 squared is 4, 3 squared is 9, and that does not equal 16. And then the same thing with the last one. 10 squared plus 14 squared does not equal 17 squared. All right, who is still a little confused? Please tell me the truth. Anyone still a little confused? I couldn't tell. Isaiah, were you raising your hand? Kind of. All right, that's okay. So basically what we need to know, I hate all these speckles on this page. Oh, well. All right, so guys, so we have 3 numbers, always 3 numbers to a triangle, correct? 2 of the numbers are going to be smaller than one of the numbers, almost always. I think that's always true. That is always true. Well, 2, 2, 2. Anyway, so the longest number or the biggest number must be in our Pythagorean theorem. The biggest number must be letter C. Okay, so of these 3 numbers, 30 is the biggest. So 30 must be C. So we're going to write, it doesn't say C, it says C squared, right? And then the other 2 numbers can be either A or B. It doesn't matter. You have to use both of them, but it doesn't matter in what order you use them. And then you're literally going to do what it tells you to do. You're literally going to square 24 squared in the calculator. Remember, 24 squared means 24 times 24 is a great big number, 576. Okay. And then 18 times 18 is 324. And then 30 times 30 is 900. I know that's hard to read. I'm so sorry. So then you're going to do exactly what it tells you to do. You're going to add 576 plus 320, which is 900. And since 900 is in fact equal to 900, that means that we could take these units. Let's say we have straws. One of the straw was 24 inches long. One of the straws was 18 inches long. And one of the straws was 30 inches long. And if we put them together, they would form a right triangle. Okay, that's what this means. However, if we took a 2-inch straw, a 3-inch straw, and a 4-inch straw, and we put them together, when the corners touched each other, it would make a triangle, but it would not make a right triangle, because right triangles will follow this pattern every time. Okay, our biggest number is 4. So C must be 4. The other two numbers, it doesn't matter if it's A or B, but you're going to use both of them. So then you do what it says. 2 squared is 4. 3 times 3 is 9. And 4 times 4 is 16. This statement is not true. That means these numbers cannot form a right triangle. Does that help? Hey, Brady. Okay. All righty. Everybody else doing okay? All right. We are talking about the Pythagorean theorem, Brady. You can go back and watch the video later. Okie dokie.
I already watched it.
Oh, you watched it? Yay, Brady. Well, yesterday's. Okay. All right. So now these questions are different. Now these questions is telling you to find a particular side of the triangle. So they give us 2 of the sides. They've left out one of the sides. So they're telling us that all of these are going to be right triangles. We only know the length of 2 sides. We have to figure out the length of another side. So let's wait, I gotta get rid of this background, you guys. Hold on one second. I'm gonna close this out. I'm so sorry. How do I get rid of the background? Can I just delete it? Oh, I did. It worked. Okay, sorry about that. All right, let's look at this one. That's better. All right, so what letter are we missing in the first one over here? And please just unmute and talk if you know the answer. What letter are we missing out of the Pythagorean theorem?
C.
C, exactly right. We're missing C. So we have A, so we know what A is. It's 5. We know what B is. It's 12. And what we're missing is C, okay? So if you're writing down notes, this would be a great problem for you to write down. All right, so now we're going to do exactly what it says. We're going to square 5. What's 5 squared? Ryland texted me 25. What's 12 squared, you guys? 144. Thank you, Jimena. Thank you, Hayden. Thank you, Ashlyn. And we don't know what C is. So now we're going to add together 25 and 144. And we get 169. Now 169 is what C squared equals.
13.
13. Yes. So if we want to find the square root of C, so a square and a square root cancel each other out. Whatever you do to one side, you do to the other. So the square root of C squared is C, and the square root of 169 is 13. So we have just figured out that C would be 13. Okie dokie. Easy peasy, lemon squeezy. All right, you guys send me the answer to this one right here. Everybody tell me what C is in the chat, please. By doing the same thing we just did. It is, Ashlyn. Good, 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 Allie. Yeah, we'll have to round on this one. This isn't a perfect square. Good, Colton. Good, Colin. Good, Hayden. So then the answer would be, good, Hamina. You might have to round it. Yep, the answer is not 65. The answer is what? It's the square root of 65, right? So we're going to plug in 7 squared. We're going to plug in 4 for B. And we don't know what C is, but we know that 7 squared is 49. We know that 4 squared is 16. And we know that 49 plus 16 is 65, but C's not 65, is it? No. Square root, C squared is 65. So then we find the square root of both sides. So those of you with these calculators, your calculator would have told you the answer is square root 65, which is good. That's an answer. That's an exact answer, actually. So if this is a multiple choice question, what is C? And this is one of the choices, then that's the right choice. However, if in your calculator, if you have the radical with a 65 and then you hit the double arrow button, does everyone know what I'm talking about? The double arrow button? Darius, do you have one of these calculators? Yeah. So does your calculator say square root 65? All right, so Darius, I want you to type, but you know that 49 plus 16 is 65, right? All right, so then in your calculator, I want you to hit okay, clear that out, hit the second green button, hit the green second button, and then you're going to hit the button that says x squared, because above it on the calculator is a radical symbol. Do you see it? All right, so you have a radical on your screen, and then you're going to type 65 under there. Okay, and it told you the same thing, square root 65, right? Okay, so then you're going to hit the enter. Oh, you already hit the enter button. Above the enter button, look on your calculator. Above the enter button is a button that has 2 arrows like that. Do you see it? Yep. And it will turn it into a decimal for you. Okay, Hayden, do you have one of these calculators? Where'd you go? Do you have one of these calculators? Are you going to get one, Hayden? Do I need to come to your house and harass you, Hayden? Do I need to mail you an ugly letter? Hayden, get a calculator. All right, so if you do that, it will give you the square root of 65, which is 8.0622577748. So if this is a multiple choice question and this is one of your options, that's the right answer. It's not going to give you both these answers because that would not be fair. That's a trick question because they're both correct. Okie dokie. How do we feel about that, everybody? Good? I have a Casio calculator. Yeah, I don't know it. Can you hold it up to the screen, Hayden? Oh yeah, see, yours is too fancy. Yours is way too fancy. You need to dumb it down just a little bit, Hayden. I'll send you a calculator, Hayden. Do you want me to send you? When's your birthday, Hayden? When's your birthday? July 2nd. Oh, that's a long way to wait. I'll send you a Thanksgiving gift, Hayden. I'll send you a long calculator, okay? Be the best gift you've ever received in your whole life. All right, let's do this one. November 5th, Jackson, are you asking for a calculator too? Where are you, Jackson? I can't even see your face. All right, let's do this one. Now, let me show you, if you didn't watch my video yesterday, shame on you, but I have to show you how to do this one. All right, so this time they give us letter B and they give us letter C. You agree with me? So we are missing letter A. So what can we do? Well, we can't do anything to A. We can square 4 and we can square 5. So far, so good? Okay, so now how do we get A by itself? Well, the first thing
we did what we did last week. We subtract 16, but we do it for both sides.
You got it, Colin. Perfect answer. All right, so when we subtract away 16, it leaves A squared by itself. Over here, it leaves 9. And then we don't we don't want to know what a squared is. We want to know what a is. So we have to take the square root of both sides. The square root of a squared is a, and the square root of 9 is 3. So this is a 3, 4, 5 triangle. 3 inches, 4 inches, and 5 inches. Okay, so sometimes to get the answer, you add them, and sometimes to get the answer, you subtract them. When will you subtract to find your answer? When they're looking for what? Let me ask again. When will you subtract to get the answer? When they're looking for either A or B, one of the legs. Yep. Okay. When will you add to get the answer? When they're asking for letter C. Okay. Now, the awesome things about these calculators I keep talking about is you can do all this in one step, you guys. So if you have one of my awesome calculators, go ahead and pull up the radical symbol by hitting second and hitting the x squared button. Are you with me? So on your calculator, all you see right now is a radical, okay? All right, so underneath the radical, you're going to type 5, and then you're going to hit the x squared button. So it's going to say 5 squared. You're still under the radical. You're going to hit plus. You're still under the radical. You're going to type 12 squared by hitting this button right here. And then you're going to hit enter. And what does it tell you?
13.
Exactly. It did it all at the same time, you guys. It automatically squared both of those numbers, added them together, and took the square root of that number. Okay? How easy is that? Pretty good, right? All right, so what about, how would we do this one? Well, we know in order to find a leg, we have to subtract, right? So under our radical, everybody bring it, clear off your calculator, pull up your radical. This time we're going to start with C because we know we have to square everything and we're going to be subtracting from the hypotenuse. So under the radical, you're going to type 5 squared minus 4 squared. And when you hit equals, doesn't it tell you the answer immediately is just 3? Okay, but you have to know before you put in your calculator, am I supposed to be adding or am I supposed to be subtracting? Because if you do all that fancy stuff in your calculator and you didn't do the right operation, you're going to get the wrong answer. Okay, does that help some of you? So if you know immediately if you're adding or subtracting and you know how to use a calculator, you can do these questions very, very, very quickly. All right, can I move on? Okay. All right, good, 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 good. Come on, let's go, let's go. Oh, and see how this one was left under a radical, square root 65, and the rest of them were all whole numbers. So when it's not a perfect square, you can leave it under the radical, or you'll have to round, and the directions will tell you where to round to. You know, round to the third number, round to the whatever number. All right, now look at this question. Was this on yesterday's quiz? I think it's actually on tomorrow's quiz. A picture like this. Who's seen this picture before? Okay, anyway, maybe it's coming up tomorrow. Now you got to look closely at this information because this tells you the letter, that a letter A is 9, but this tells you C squared is 225. So that means, what is the length of this side, guys? If the area of this square is 225, what is just the length of C? How would you find that out? Rylan already said the answer is 15. How do you know, Rylan? How do you know the side length is 15?
Adding.
Where did we add from this to get 15? Yeah, so if this is a perfect square, guys, right? So if the area of this perfect square is 215, to find each side length, you must find the square root of 225. So under the radical, if you pull up square root 225, it tells you that C is 15. So if we are filling out this little thing over here, we know already that A is 9, right? we know it didn't ask us c squared, but we know by the picture it's 225. And so now we know that c is the square root of 225, which is 15. Okay. Now, do we have enough information to figure out the rest of these blanks?
Yes.
What are we going to do? Tell me what to do, Colin.
First off, let's do on the a squared. So we
Mhm.
basically do so basically we do nine I can't remember.
Squared, 9 squared.
Yeah, that's what I'm trying to say. 9 squared.
And what is that?
81.
81. I agree with you. All right. Now what can we do?
Since we already have 2 lengths,
Mhm.
we can do 15 minus 9 and get 6. That's what we do how to get the simple b, you know.
All right. What now? So we're going to do 81 here. I'm sorry. I honestly, I
I meant-
stopped listening to you.
I'm sorry, got confused. Okay, sorry.
Okay, that's all right. So now what
Um,
can I do?
So then you subtract 81 from both sides
Okay.
and you get 144. That's what
Okay.
I got.
All right.
Then we could choose a square, but we already know it's 12.
Okay. So what do I fill out down here? What is b squared?
B squared is 144
And what-
and the simple version is 12.
That's it. Did y'all get that? Yeah? Anyone totally lost? No? Okay. So can we do another one? You guys try one? It's like you have parts of the puzzle and you got to put the puzzle together. Okie dokie. All right. Oh, I didn't have another example. Darn it, Miss Richardson. Okay. So what time is it? When did we get out of here? Oh, this is perfect, you guys. All right. So sometimes you'll have three-dimensional figures, and the Pythagorean theorem can help you do that. Now, they want me to teach you a long way. You do this Pythagorean theorem, and then you do another one, and then you put it all together. But I'm just going to show you the quick and easy way. Good for you? Do you want to know the quick and easy way? So when you have a three-dimensional figure, this is the formula that you're using down here. So basically, they're wanting to know what is the diagonal of this box. So all regular boxes have 90-degree angles, right? So you could think of the bottom of the box as a right triangle. And then you could think of this side of this is one side of the one leg of a triangle. Across the bottom is one leg of a triangle, and the diagonal is the three-dimensional hypotenuse of the across the box from bottom to top. So when you have 4 or 3 numbers and you're looking for the letter D, basically, this is the formula that you use. So basically, you're just going to square everything, add it all together, and find the square root of the answer. That's what you're going to do every time you have a three-dimensional box. That's the quick way to do it. All right, so let's look at one that's been done. All right, here's our three-dimensional box. It has a length of 6, a width of 10, and a height of 15. Since we have 3 numbers, we're going to square them, all of them together. We're going to add them all together, and we're going to end up finding the square root of the answer. Okie dokie. Ashlyn, you're so quick. All right, so 6 squared is 36. 10 squared is 100. 15 squared is, I think, 225. Is that right? I think so. All right, add up all those numbers.
361.
361. So how do we get D? We find the square root of both numbers. So the square root of 361 is 19. Okie dokie. And with our super duper calculators, we could have just put all of this under the radical all at the same time. Make sure you square them though. If you just put 6 plus 10 plus 15 under a radical, you're going to get the wrong answer 100% of the time. And it will spit out this wonderful whole number 19. Okie dokie. Can I move on? Can you guys do one on your own? Is that the same numbers? No, it's not. Hey, let's do this one. Let's do this one. Once again, you're finding that diagonal across the rectangular prism. Everyone tell me what the diagonal is. Oh, it's not a perfect square, so we're gonna round it. Let's round it to the nearest hundredths. Hundredths. Go out to the second decimal place, not hundreds. Good, Ashley. Good, Colton. Good, Colin. Isaiah, do you have my calculator? Nope, yours is too smart, Isaiah. You got to get a dumber calculator. I don't know how to use that one. That's the thing. I mean, I do know how to use it, but they're all a little different. So if we all have the same calculator, that's what I've been saying all year, people. Who should I yell out? Who am I yelling at? Who needs a calculator like mine? Claire, I had you last year. You better have this calculator, girl. Do you? Yeah, it's right. All right, 11 point hundreds, people, hundreds. So the answer is 11 point. Yes, Ashlyn, your brain is probably smarter than all of our calculators put together. You're fantastic. All right, so if you have the radical, so on your calculator somehow, Isaiah, you can bring up a radical. I don't know how, but I'm sure you can figure out how to bring up that radical. And you're just going to type in it 5 squared plus 8 squared plus 6 squared. You hit equals, and our calculator says 5 square roots of 5. But then if we hit the double arrow button, we find the answer is 11.18. Okie dokie. All right. Any questions? Okie dokie. All right, how about this? If you don't have one of these calculators I keep talking about and you want to come up to Cherokee Bluff Middle School and I'll let you borrow one, then let me know when you can come and I'll have one in the front office for you. Okay? All right. So guys, I think that's about it. Oh, no, it's not. Just kidding. All right. So, we only have 3 minutes. We're having so much fun. I hate that. Maybe I'm actually gonna, you know what? Actually, this is exactly where I was gonna start on Monday. So this is a perfect place to stop. All right, so you do have a quiz, one more quiz all about the Pythagorean theorem. Yeah, I'm at Cherokee Bluff Middle School. I'm at Cherokee Bluff Middle School if you are going to come up here. Or you can stay after chat and let me know what we're going to do to get you a calculator. Okay? Oh, so you're gonna do another quiz tomorrow, and some of the questions are like this. So make sure y'all know how to do that, okay? All right, everybody feel good about everything? So if you're good to go, then have a great day. If you want to stay around a couple minutes and ask me something, please do so.
I
Okay.
do have one question.
Okie dokie.
On the quiz, it had a little thing where it said the square root of like.
Wait, hold on. Don't, Hayden, don't leave. Okay.
The
go ahead.
square root of 289.
Uh-huh.
And it also have the actual square root of 17. Should I click like the square root question answer or just 17?
They're both a multiple choice.
No, it was a one choice only. For me, it was only one choice. So I picked 17.
Yeah, I mean 17 is the square root of 289.
I got some questions wrong, so I'm just wondering, was it that one? Because there was technically 2 right answers.
Okay, let me pull up what you're talking about because that worries me if there's 2 correct answers. That's a trick question. I'd never do that on purpose. Was it tomorrow's assignment or yesterday's assignment? Do you remember? Colin?
Sorry, zoned out.
Was it yesterday's assignment or tomorrow's assignment?
Yesterday's.
Okay, let me look at your attempts. Okay, Colin Johnson. Colin Johnson. All right, so one of them was the one that has 17 as an answer. Oh no. Oh no, you missed it completely. It's neither of those answers. Sorry.
Wait, neither?
Neither 17 or the square root of 289. Those are both the options, but neither of those are the correct answer.
Oh, okay, so I got that one wrong.
Oh, and I know why, because you didn't read the question. It's asking not what C is, but what the perimeter of the triangle is. And I think, Jackson, you did that too. You have to read it carefully. It's asking you
I'm
the
sorry,
perimeter.
I thought it meant by the perimeter of the, sorry, I didn't read the question.
So 17 is the side length, but you have to add those side lengths together now.
Okay,
Okay.
thank you.
You're
Bye.
welcome. Bye. All right. And Jackson, I think you missed the same question because you did the same thing. All right. So Hayden, let me see what message you sent me. All right. So Hayden, I'll be at school this Friday for the pep rally. All right. So you're going to pick up a calculator this Friday at Cherokee Bluff Middle School. What time will you be here? Oh, 2? Perfect. Okay, so I'm going to make a note. Now, this one is you're going to be borrowing it. So you got to turn it in to me at the end of the year, okay? So let me write Hayden. Calculator. Friday by 2. Okay, it'll be in the office, but because I'm old, I'm almost 50, Hayden. Aren't you sad for me? During advisement on Friday, please put a note in there. Miss Richardson, please don't forget, I'm coming to get my calculator today. Okay, will you remind me, please? Just in case. Don't bring me hard candy. Okay. Okay, Hayden, bye-bye. Isaiah, so what were you saying? Were you coming up here to get a calculator as well?
No.
Okay. No, I was just getting on to Kellen a little bit this morning because he was kind of raising his voice at me and I was going to get on to him, but he left before I could. So that's all I was going to remind him that, even though we're virtual and I can't hear him yell at me, he was obviously doing it on the screen. And so I was just going to remind him about his manners. That's all I was going to tell him. Okay.
Yes, ma'am.
Will you take care of your little brother for me?
Yes, ma'am.
Don't you hurt him, Isaiah. Don't you hurt him.
I
Don't do it. Of course you don't. All right, buddy. Have a great day. Bye. Caden. What's going on, Caden? How you doing, buddy? Oh, I meant to stop recording. I'm sorry. How do I stop recording? Oh, there it is.